today on how it's made. Surgical instruments. Ketchup. Double-decker buses. And walking sticks. Surgical instruments have evolved with the science of medicine. They actually date back thousands of years, when primitive man used crude implements to cut holes in skulls to release evil spirits. Medical science has come a long way since then, and today's surgical tools are among its advancements. In the hands of a skilled surgeon, the right tool can be a lifesaver. There are now hundreds to choose from, each designed for a specific task or operation. Made of surgical-grade steel, which is extremely corrosion-resistant, they can withstand frequent cleaning and sterilizing. One of the more useful tools is a self-retaining retractor, which is used to pull back tissues or organs during surgery. Using a circular cutter, they round the profile of the tool's joint. This round joint allows the tool to open when the shanks are shut, the opposite of a pair of scissors. Next, cutters carve slots in two parts to create the retractor's intermeshing jaws. These jaws will be used to grasp and retract body tissue so the surgeon can operate. A technician sands the teeth down to a precise size. He must be accurate within 1/4 of a millimeter. He then smooths the jaw's teeth against a fine grit wheel so they'll easily intermesh when needed. He rounds the tips of the teeth to make them blunt so they won't damage human tissue. He hammers back the tips of the teeth, giving them a claw-like profile. With the teeth now complete, attention returns to the round joint of the instrument. The carved slots and countersink allow the two sides to fit together perfectly. They install a part called the rack below the joint and file teeth into it. It will be used to lock the tool in an open position. After heat treatment, a worker sands all the tool components to smooth sharp edges. Vibrating porcelain chips and polishing compound scrub them clean and remove burrs caused by machining. Next, they install the pivot screw and trigger for the rack. By pressing it, the surgeon can open the prongs to the desired width and lock the tool in position. Production now moves to the surgical clamp. It's used to block the flow of blood during operations and has a more scissors-like joint, rectangular instead of round. Mechanized cutters carve the joint and catches. A worker forces the finger bows against the spinning grinding wheel to remove surface imperfections. Precision is again critical, as the worker grinds each of the tool's shanks to the correct thickness. He measures to confirm that the size is consistent along the length of the part. He then files the joints so they mate perfectly. He places the joint part of one of the shanks over hot coals to soften the metal and make it malleable. Then he forces a spike through a slit in the joint, and the now compliant steel stretches to open the slit. The other shank now slides easily into the opening. He hammers the joint to close the opening, and the two arms of the surgical clamp are now hinged together. Next, he files the teeth of the clamp so they'll interlock when the tool is closed. He bends the two ends around a tool to form the jaws of the clamp. These curved jaws will come in handy when the surgeon needs to reach around organs or bone. Next, using a variety of tools, he adjusts the shanks and the finger bows to give them a more ergonomic feel. This is called soft setting, because at this point, the metal is still soft enough to be manipulated. He tweaks the bend of the jaws until he's satisfied with the curvature. He smooths the inside of the finger bows with a fine abrasive belt. After heat treatment to strengthen the metal, they blast it with fine glass particles to give it a satin finish. They laser etch the company name and identifying numbers onto the surgical clamp. The numbers will allow the tool to be traced back to a particular production run. And now it's ready to take its place on the front lines of healthcare. Ketchup has a questionable past. According to one theory, it comes from the Chinese ketchup, a type of sauce. Another theory traces it to European pickling sauces, and yet another claims Arabic origins. But there's widespread agreement on where it ends up, on hot dogs, hamburgers, and French fries. Tomato ketchup recipes vary only slightly, as consumers expect a certain familiar tomato-y taste. This U.S. company produces all-natural ketchup, made entirely of certified organic ingredients. Tomato paste, agave nectar, a natural sweetener, onion powder, spices, salt, and white vinegar. The tomato paste, not surprisingly, is the base ingredient. It arrives at the plant in huge bins, which have been vacuum-packed to preserve freshness. After unsealing each bin, the factory's quality control technician scoops a sample for testing. This is to make sure the thickness is just right. If the sample gets the okay, workers slide the bin under a powerful air-driven pump. Then they flip a switch, and the pump begins moving the tomato paste to a large holding tank, transferring nearly 140 kilograms of this ketchup base in less than 10 minutes. At production time, an intricate system of piping transfers a specific amount of tomato paste from the holding tank into a cooking kettle. As the paste cooks, a mixer continuously revolves to keep it from sticking to the sides and to blend in the onion powder workers add next. This and the upcoming ingredients have been pre-measured to be in correct proportion to the batch size. The next ingredients are salt, then, as a sugar replacement, nectar from the agave plant. They pour in an initial amount, mix a bit, then pump in the remainder. The last ingredient is white vinegar. For competitive reasons, the company won't divulge the mixing time, cooking time, or cooking temperature, all of which are key elements of this top-secret recipe. On the packaging line, an alignment machine stands the plastic bottles upright as they make their way to the filling machine. The finished ketchup, meanwhile, is passing through an elaborate system of cooling pipes en route to the filler. And let the bottling begin. The machine fills 8 bottles at a time, 150 bottles per minute. The factory tests every batch of ketchup it produces to ensure the correct consistency in every bottle. The next machine, appropriately called the capper, places a plastic flip cap on each bottle, then, with spinning circular belts, twists it on securely. The next machine cuts a decorative neckband made of plastic film and slips it over the cap. Each bottle then passes under an air jet. The air blows the neckband downward until it's positioned under the cap. Then a quick blast of hot steam shrinks the band to a tight fit. The next machine presses on 2 adhesive labels, one on the front of the bottle, the other on the back. Then it's off to the packing and shipping area. A sealed bottle of ketchup stays fresh for at least a year because the vinegar in it acts as a natural preservative. Ketchup also has health benefits because it's chock full of tomatoes, which are high in lycopene, a powerful antioxidant believed to protect against many types of cancer. Double-decker buses have long been a fixture on the streets of London, England. A typical double-decker carries 60% more riders than a regular bus. And though quintessentially British, nowadays you'll find London-style double-deckers on the streets of several major cities throughout the world. Every bus design undergoes rigorous stability testing. They fill the prototype with lead weights to simulate a full passenger load, then tip the bus to a 28-degree angle, the side wheels lifting about shoulder height off the ground. If the vehicle doesn't keel over, the design passes the test. The bus's underframe, the chassis, is made of welded steel. They construct it in 3 separate modules, front, center, and rear, then set the 3 modules in an alignment jig to be welded together. Once that's done, welders add a steel structure that'll support the floors, seats, and body panels. They clean the chassis and paint it with an anti-rust epoxy. After baking on the paint, they seal the gaps between the welded parts with polyurethane. This prevents water penetration, which would cause internal corrosion. Meanwhile, technicians bolt the 6-cylinder 250 horsepower engine to the automatic transmission and connect the hydraulic lines and other piping. Then they wheel this engine pack over to the assembly line and bolt it to a bar at the rear of the chassis. By suspending the engine, they shield it from impact damage in the event of a rear-end collision. They also install the radiator, battery, and other components. At the front of the chassis, they install the driver's binnacle, on which all the controls are located. Unlike a stationary car dashboard, for driver comfort, the binnacle tilts with the steering column. After installing the front and rear axles, technicians mount the wheels. Each one is more than a meter in diameter and weighs 45 kilograms. The engineering specs require the wheel nuts to be turned to a specific tightness. Workers also install the driver's seat and the vehicle's 275-liter gas tank. The complete chassis goes onto a test drive machine, which simulates varying passenger loads and road conditions. A camera pointed at the binnacle records the accuracy of the speedometer and whether any warning lights illuminate. Then it's into the body shop, where workers mount fiberglass boxes over the wheels. Another team builds the interdeck floor, the aluminum frame structure that separates the bus's two levels. They affix the lower level's melamine ceiling to one side and the upper deck's plywood floor to the other. To make the roof, they construct an aluminum frame, then glue an aluminum sheet onto it. Most of the bus's body is made of aluminum because, compared to other metals, it's lightweight, durable, and easy to repair. Next, they paint the roof and install components integrated within it, such as the aerial antenna and wires for lighting. As this computer animation illustrates, step by step, the bus is slowly taking shape. Workers insert the pegs underneath the roof into aluminum pillars running the perimeter of the upper deck. Along the sides, workers sandwich the structural frame between inner and outer aluminum body panels. First, they affix the inner ones. Then they fill the spaces in between with blocks of foam insulation. Finally, they glue on the outer side panels, pressing out the excess adhesive with a roller so that the panel lays flat. The front and back of the bus are made of molded fiberglass. They have openings for windows, and in the back, a cutout beneath the top window for the upper deck air conditioner. As one crew glues all the window glass into place, others install the doors, and inside, the upholstered seats and a durable, non-slip floor covering. Once the bus comes back from the paint shop, the factory's quality control department inspects the interior. The seat fabric is dark and patterned to discourage graffiti. The bus also has 12 cameras hidden in various locations to deter vandalism. The typical double-decker is 10 meters long and nearly 4.5 meters high. It carries up to 92 passengers. When you need something to lean on, a walking stick can provide the necessary support. Wooden walking sticks have been coming in handy since primitive times. The first versions were likely crude branches, but they've evolved into something much finer. Today's wooden walking sticks are designed to support the user in style. There are rustic versions for the outdoor adventurer and distinguished-looking ones for getting around town. But whatever the style, a walking stick adds stability to the human journey. It all begins with these 3-year-old saplings. These ones are chestnut, a lightweight and durable wood. Once the sticks have been peeled and dried, it's into the washing machine to scrub off any dirt or mold that may have accumulated. And it's not your usual washing machine. This one is a long tank sized specifically for these sticks. A worker closes the lid tightly so no sticks will spill out as the tank rotates in a trough of soapy water. After a few minutes of tossing about, these sticks come out squeaky clean, and they're ready for the steamer. The sticks are steamed for 20 minutes, and this makes them soft enough to bend. So next, he secures the stick and activates a spring-loaded arm. It wraps one end around a form to curl it into a crook. He ties it so it holds the crook shape and retracts the bending arm. This crook will serve as the walking stick's handle. A century ago, crooks were formed entirely by hand, which took brute strength. But with the invention of this nifty machine, the job became a whole lot easier. Next, it's over to a device called the straightening horse, because it's used to straighten the stick shaft. This job does take a bit of muscle, as the worker wrenches the shaft between posts to set it straight. With the shaft now quite linear and the end curled into a crook and still tied, it's time to set the shape of this walking stick. And so, it's into the drying room for a couple of days. The temperature in here is around 80 degrees Celsius, and as the sticks dry, the shape solidifies. A worker then cuts the stick to the correct length, and he also pares down the end to prepare it for capping later. He also sands down the knots in the wood, creating a smoother surface. From a simple sapling to a cane shape, it's quite a transformation, and it's not over. The next worker exposes the wood to a flame just long enough to blacken it. This is staining without the chemicals, and the finish is distinctive. He now turns the walking stick against a very sharp circular blade to carve spirals on the crook and down the shaft. It's a candy cane look, and achieving it is a bit tricky. This is where on-the-job experience counts. Another worker then trims the end of the handle crook. The cut-offs won't go to waste. They'll help fire the factory furnace. Next, a worker inserts the crook in a machine that works like a pencil sharpener, except the blade inside rounds the end. This process is called nosing the stick. The stick that started out as a peeled sapling now looks dramatically different. A dip in water-based lacquer gives this walking stick a high gloss. They hang it to drip dry for an hour, after which the walking stick is ready for the end cap, or ferrule. Ferrules come in a variety of styles. There are blunt ones for a good grip on indoor surfaces, and there are pointed ferrules for navigating rougher outdoor terrain. After hammering the ferrule onto the stick, he drives a nail through it to secure it. These walking sticks are now complete. All that's left is to hang around until the orders come in, and those orders are usually very specific. Customers get to choose the length of stick that's appropriate for their height, as well as the style and finish they prefer. From a simple stick to a dignified-looking cane, it's been quite a journey. The path ahead may be uncertain, but with one of these walking sticks in hand, a person is well equipped to make his or her way in the world.